All right, so we're back. I've added a little section here. We're going to talk about error checking, which will come up in the future. But for now, just eliminated some stuff. We're going to start over from other parameter types. So we know now that param reader, we're just going to abbreviate this PR because I don't want to keep writing param reader. So PR, we've set PR and we've got next from it, and we've also done PR.next line, right? So these are two things we've done in order to capture input from the user. However, this doesn't take everything into consideration. Let's say we had an integer declared. So integer new int equals PR.next, right? It's going to actually throw an error here. And it's going to throw an error because you're not allowing the compiler to convert from a string to an integer. And next, like I was telling you prior, only takes in strings primarily. It's just the safest case. It's always going to know, hey, you know, it's no matter what you enter here, I'll be able to handle it for the most part. There are some exceptions, but for the most part, same thing with next line, right? Next line is saying, I'm waiting for you to terminate that string with a return character. So this all makes a very big difference in how the compiler reads in these things. So if we wanted to specifically take in an integer, we would name this next int. So this is then going to take user input in the form of an integer and store it into new int. That's what it's going to do. And that's, part of that whole assignment, right? It's assigning whatever comes in through here into new int. However, we haven't told the user to do any of this, so let's just tell them, please enter a number. So let's run this and we'll see. And save it. Okay, cool. Enter a number, 15. It gets stored. Nothing happened, right? So what happens though if I go ahead and I enter a string here, or even any word, right? So if you think about it, it's gonna fail. It's gonna fail because this is waiting for an integer. But let's just see it. So it's actually gonna throw back the error. So this is the problem that we run into when we don't have that whole section that I was talking about, this error checking. So error checking is going to allow you to make sure that whatever the user entered is a viable input. It's kind of how if you're ever completing a form online and it says please enter your name and you enter a number or a special character or you put a capital letter in the wrong spot, the code will say, hey, something's not right here. Or if you enter a password, right, and it's like your password needs to have one uppercase letter, one lowercase letter, one special character, one number, blah 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 blah, right? All of this is done through statements that make your code more robust. Error checking. So let's go ahead and talk a little bit about error checking in the next video. But for now, we'll just assume that the user is God's gift to Earth and is giving the proper input and output every time. So now that we've saved new int, we can now modify it and give it back to the user. So we can say sysout, or we can even manipulate it here. We can just say new int equals new int divided by 4, right? So how is this going to work? So let's say in the case that I entered last time 15, right? In this case. So it didn't return anything because we haven't told output to the user, but what did happen here? What do you think happened here? Well, 15 divided by 4 is what, 3.75, something like that. So you would think like, oh, it's just gonna store 3.75 into new integer, right? We took 15 divided by 4, it's gonna store 3.75. Well, that's not the case, and here's why. Because we said this was an integer, not a double or a float. I know this might be obvious to some and not so obvious to others, but I just want to cover that what happens in this scenario is maybe not so intuitive. So it's actually going to round down. In programming, an integer notation or converting to an integer, it always rounds down. This code does not know how to round. There is rounding functions built in, like this dot next int, that's a function call. There is something called dot round, and you can actually round it to the appropriate measure, like the way that we think of it, 0.5 and up rounds up, and 0.4 and down rounds down. That still exists. So we can do that, but it's not going to work quite so well in this situation because we were dealing with integers, and the integers functionality is just saying truncate. As soon as I see, you know, 35.446, I just see 35 and just destroy everything past that. I don't care about any of that. It's just 35 at this point. So in our case, we would expect to see, if we sys out new int, we would expect to see 3 here, because that is 3.75 truncated. If I put 15, there's your 3. So you might say, okay, well, I don't want a 3. I want, well, we should also tell the user, you know, your number divided by 4 is plus. Sweet. So you might want to actually store the correct one, in which case we'll make this a double. We could also make it hit float, but for our sakes, we're just going to keep it as double. Just because it's easier. New int doesn't exist anymore. Double. And we change this here to double. Right. So let's run this again. We say 15. It's going to give us 3.75. So that is the output that we expected it to give us. Does that make sense? Awesome. We'll pick this up next time.